Welcome Algebra 1 students. Today we're just going to do a little review video of solving quadratics. When we have our quiz on solving quadratics, I will not tell you what method you have to use to solve. You get to pick which method, and that's why we did that last time we were together. We did that little lesson where we talked about what the best method is to use to solve, and then you had to do that writing assignment. So let's just do some practice of actually solving those quadratics and picking that best method along the way. So if I saw this first one on a quiz or a test, I would first think, well, number one, I can't use square roots because there's a b value. So number two, I always like to check to see if factoring works. So again, I'm going to check to see if there's a greatest common factor. Doesn't look like there's a greatest common factor, so I'm going to go ahead and make my x. So again, I'll label A, B, and C. Take A times C for the top of my x. Looks like I get negative 10 on the top and B on the bottom, which is 3. So I got to find two numbers that multiply to a negative 10, but are going to add up to a positive 3. It looks like those two numbers would be 5 and negative 2. Again, I would double check 5 times negative 2 is a negative 10, 5 plus a negative 2 is a positive 3. So it looks like the x works. So I'm going to go ahead and use factoring to solve this quadratic. You could also use quadratic formula because we know quadratic formula works on every quadratic. So that is up to you, but I like factoring if I can use factoring because I think it's a little bit easier and less work than the quadratic formula. But again, totally up to you. So now that I have my x that works, I'm going to go to my box. I put my first term in the first box, last term in the last box, my two terms for my x, so 5x and negative 2x. Again, from here, I just go ahead and I pull out my greatest common factor. So it looks like I can pull an x out of this first column. The second column looks like I can pull out a 5. First row looks like I can pull out an x. And this last row looks like I can pull out a negative 2. So that means if I'm rewriting this quadratic in factored form, I can rewrite it as x plus 5 times x minus 2, and it's still set equal to 0. Once I have it in factored form, I get to use the zero product property, which says if this entire thing is 0, then, and I'm multiplying, one of these two factors has to be 0. So in order to find my solutions, I just set each factor equal to 0. So I say x plus 5 equals 0, or x minus 2 equals 0. Solve each for x. So it looks like on the first one, I get x equals a negative 5. So there's one solution. The second one, I add 2 to the other side, so I get x equals a positive 2. So those are my two solutions to my quadratic, or those would be my two x-intercepts on the graph. As always, if you want to, you can definitely take them and plug them into your quadratic, and it should give you a true statement in the end telling you that you did it correctly. So there's the first one that we solved using factoring. Let's try another one here. So if you saw this one on a quiz or a test, I'd be thinking, well, gosh, there's no b value. So if there's no b value, I'm always going to use square roots to solve. No b value. So if there's no b value, that means we just solve for x. So I'm going to go ahead and cover up x. I'm going to add 12 to the other side first. So I get 3x squared equals 12. From here, I'm going to go ahead and divide each side by 3 because I want to get x by itself. So I get x squared is equal to 4. From here, to get rid of the square, I know I undo squares by taking square roots. So I'm going to take the square root of each side. Since this is an equation, again, those two things cancel out, so I just get x. I want both the positive and negative square root, so plus or minus square root of 4. So that means x equals a positive and a negative 2. Again, you can write it in this notation. This indicates that there's a positive 2 and negative 2. Or if you wanted to, you could say x equals 2 and x equals negative 2 if you wanted to write them separately. Either way is fine. Again, square roots is definitely the best method here because there's no b value. Again, if you wanted to use quadratic formula, you definitely could. Alright, so here's another one to solve. So again, instantly I'd be thinking, well, can I use square roots? And the answer would be no, because there's a b value. So my go-to is I always check the x. I want to see if I can factor. Again, before I factor, I look for if there's a GCF, and it doesn't seem to be the case. So I get to go right to my x, a times c, so 3 times -5, I get a -15 on the top, and I get a +3 on the denominator. So I got to think of two numbers that multiply to a -15 but add up to 3. And I might be thinking, gosh, well, 5 and 3, but if I use 5 and 3, let's just say I make the 3 negative. 5 times -3 is definitely a -15, but that does not add up to a +3. So unfortunately, if I get out my red pen here, the x does not work, right? We can't factor here. So since we can't factor, that means we got to use the quadratic formula. So again, just as a recap, quadratic formula looks like x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Again, a great thing to have memorized. So I'm going to go ahead and rewrite this. Wherever I see my variables, I'm going to put parentheses. Kind of run out of space there. Oops, over 2 times a. So I'm just going to go ahead and plug in a, b, and c. So I plug b into those first two parentheses because that's where b is at. So b is 3. 4 times a is also 3. Times c, which is a -5. So I'm going to sneak that in there, over 2 times a, which is 3. So we know when we're doing this, we got to simplify what's under the radical first. So let's go ahead and start there. So I get x equals, just simplify along the way, I get -3 plus or minus a square root. I got to square it first, so 3 squared is 9. Minus 4 times 3 times -5, all over 2 times 3, which is 6. Keep simplifying within my radical, so I get x equals -3 plus or minus a square root of 9. Then I got to take -4 times 3, which is a -12. Then I got to take -12 times -5, which gives me a +60 divided by, still by 6. Still got to keep going. I keep simplifying within my radical, so I get -3 plus or minus the square root. Just add those two numbers together, all divided by 6. I keep going. I got to simplify my radical. Unfortunately, square root of 69 is not a perfect square, so we are going to have a decimal, but that's okay. So I get x equals -3 plus or minus. When I take the square root of 69, I believe I'm going to get, it's a decimal, right? It's going to be 8.306. We're always rounding to two places though, so I'm going to say 8.31. 0 bumps up to a 1 because after the 0 is a 6, all divided by still that 6. Now I got to find my two solutions, so I'm first going to start by adding to find one of the solutions. So I get x equals -3 plus 8.31 divided by 6. So I'm going to add those two numbers on the numerator together first. So I'm going to have 5.31 divided by 6, which is going to give me, again, if I'm just rounding to two places, 0.89. So there's one of my solutions. Again, I got to find the other one, so now I got to go back up here, and I got to now subtract. So I'm going to take -3 minus 8.31 this time, divide it still by 6. Looks like I get x equals -11.31 divided by 6, which is going to give me 1.94. So there is my second solution. So I get 0.89 and 1.94. So again, there was a problem that we had to solve using the quadratic formula simply because there's a b value, so we can't do square roots. X didn't work for factoring, and we see why it didn't work because our answers were kind of messy answers, or they're decimal answers. All right, one last one to get some more practice of just solving quadratics. So here's our last one. Again, I should have maybe brought this up for all these. You always have to make sure they're set equal to 0 first, and luckily all of these have been set equal to 0, so we've been good. So to solve this one, again, I'd be thinking, well, square roots, can't do square roots because there's a b value, so I'm going to see if I can factor. So I'm going to start by making my x. Again, there's no greatest common factor I can pull out first, so I can go right to my x. So I take a times c, it's going to be a -7, b on the bottom, which is a -5. Are there two numbers that are going to multiply to -7 but add up to -5? The answer would be a big fat no, so that means we can't use factoring to solve. So again, just like the last one, we have to use quadratic formula. That's our only option. So again, I'm going to start by writing the quadratic formula. A squared minus 4ac all over 2a. I'm going to rewrite it again, putting in parentheses where I'm going to plug information into. And now I'm going to fill in my information, my a, b's, and c's. So first I'd fill in b into the first couple parentheses. B, it looks like from my quadratic, is a -5. A is 1. And c is -7. Just filling right into our formula. From here again, we go ahead and we simplify what's under our radical first, or our discriminant. So I get x equals a -5. I can simplify that as I go, so that's going to give me a +5, plus or minus the square root. X1 is first, -5 squared is 25, minus 4 times 1 times a -7, all over 2 times 1, or just 2. So I get x equals 5 plus or minus the square root of 25. -4 times 1 is a -4, times a -7 is a +28, all over 2. Keep going inside my radical, so I get 5 plus or minus the square root. 25 plus 28 is going to give me 53, all divided by 2. So keep going, I gotta simplify what my square root is. Unfortunately, again, 53 is not a perfect square, so now we see why factoring didn't work, right? Because we're gonna have some decimal answer. So I get x equals 5 plus or minus the square root of 53, which again you'll have to do on your calculator to get that decimal answer. Looks like if I round to 2 places, 7.28 all over 2. From here, I can go ahead and find my two answers. So if I start with adding first, I get x equals 5 plus 7.28 over 2. So it looks like x is going to equal, if I just take 5 plus 7.28, I'm going to get 12.28 divided by 2. So it looks like here, x is going to be 6.14. One of my solutions, 6.14. Sweet. Lastly, I gotta find my last solution, so now I'm gonna go ahead and subtract. So I get x equals now 5 minus 7.28 divided by 2. So when I subtract here, 5 minus 7.28, simplifying that numerator first, I'm gonna get a -2.28. I'm going to divide that by 2. Now that I've simplified, looks like my second answer is a -1.14. So those are my two solutions to my quadratic, or sometimes we call those zeros, sometimes we call them roots. Again, another word for those are our x-intercepts. That's 6.14 and -1.14. So this video was just a quick review video of our methods that we have learned to solve quadratics. Once you are done with this video, I do have a little quizzes assignment. Again, quizzes is like Kahoot. I just have some questions on there. They're multiple choice with solving, so I please ask that you go do that once you are done with this. And that would be your assignment for today. As always, if you have questions, please email me at storantflip@gmail.com. Thanks and have a great day.